Okay, so light and colour, P14.3. So if you look, this was discovered by Isaac Newton when he went to a fair. He picked up a prism, and a prism was a glass triangular box, and it was considered like it was the PlayStation of its day. And what they did was, if you fire some light in at the prism, it would come out the other end. Now, if you shone white light in, now white light is a mixture of all the different types of light, and what happened if you shone it through the prism was that the different colours of light would be refracted by different amounts. Okay, and what Isaac Newton did was, Isaac Newton decided, well, that's interesting. What would happen if I put in something that blocked all the other types of lights and only let orange light through, and then I put another prism in its way, and I tried with my orange light, if maybe what will come out the other end will be white light again, because it'll have all been reformed, but it didn't. This time the only thing that came through is orange light. Okay, so therefore he realised, oh, hang on a minute, what's actually happening is that this white's not actually a colour. White's a mixture of all of the other colours. And when you refract it using a prism, the different colours are refracted by different amounts. Interesting in itself. But if I try and refract them again through a prism a second time, I only get that one because I've put in monochromatic light here. Monochromatic means one type, one colour, one wavelength. Okay, so the other thing is that's the correct thing there. So red is refracted less than blue. Okay, and the thing about red light is red light has got a longer wavelength than blue light. Blue light has got a shorter wavelength, which is what we were just doing when we're doing about infrared and ultraviolet. Okay, so that would tell you that the shorter the wavelength, the more refraction you're going to get. Okay, the more refraction it's going to get, the greater the angle of refraction. Now, the next bit is, what do all these colours of light help us to do? How can we explain colour surprisingly easily? Okay, so let's say that I've got a white surface. So I've got a white surface in front of me, and I shine white light onto my white surface. Now, from a physics point of view, we say that there are three primary colours. We say that the three primary colours are red, blue, and green. Now, not yellow. Yellow's for art, and the reason why art say yellow is a primary colour is because it's very hard to mix paints together to get yellow, whereas it's very easy to mix lights to get the different colour light together to get yellow. Okay, so we don't have the problem that art do. So our primary colours are these three. Okay, so white light is made up of the three primary colours. One. So this is white light being shone onto a white page. And what's reflected is all three of them. That's why it's white, because it's reflecting all three of those colours. Now, let's say that we had a red page instead of a white page. And this time we shine white light onto it. So again, all three primary colours. But this time, the red book only reflects red light. So it looks red, it absorbs the blue and the green. So if you remember when we did about heat, and we said that matte black objects were the best at absorbing. Well, now you've done both the two things that tell you why matte black objects are the best absorbers. So the firstly is it's rough because it's matte, so that gives you diffuse reflection, so it can be, it gets multiple chances to, so when it comes in it might come back in and hit there and it can't escape so easily. And secondly, when you shine white light on it, all three of the primary colours are all absorbed. Nothing is reflected by the matte black surface, okay? So matte black absorbs everything. Which is why black objects get hotter faster when you shine infrared radiation on them than silver objects. It's also why they emit more, because they emit more of those colours as well. Right, so that is why red books are red, why black objects are black, why white objects are white. Interesting. Next thing we need to talk about is why are yellow objects yellow? Okay, yellow objects are a little bit harder. So I've got yellow, and like I said, and remember I said in physics it's very easy to make yellow light. Well, this is how. So let's say that we shine white light onto our yellow object. Now, in order to make yellow, you need red and green. So that would look yellow because it's absorbed the blue and left behind the green and the red. When those two combine, they make yellow. That's how you get a yellow surface. But what happens if you shine red light onto a yellow surface? Just red light this time. Well, if you shine red light onto a yellow surface, the surface won't look yellow. The surface will look red because there's no green light there to reflect, so it looks red. Equally, if you, and that goes the same for all of the colour wheels. So all of the parts of the colour wheel that you get, if you only reflect one of them, that's the colour that you look like. Okay, the next thing that I want to talk to you about is filters. Okay, so if you've got a blue filter, blue filters let through blue light. So if I shine green light to blue filter, it can't go through. If I shine red light to blue filter, it can't go through. Okay. Now let's say that I put a green light in front of that blue light that I've just filtered off there. Now no light will go through. Okay. So filters. So surfaces reflect the colour that they can, which is the colour that they are, under white light. It can be more than one, it can only be one, it depends on whether it's a primary or a secondary. Filters let the colour they are go through. So blue filters let through blue light, yellow filters let through green and red light, and so on. But if you don't have any of the colour that you can go through, then none gets through and it looks black. Okay, and then what we've got is translucent, transparent and opaque. Transparent will let everything through, translucent will let some through, and opaque will let none through. It depends how you are on that scale. So. Transparent, translucent, opaque. And the easiest way to think about that is like a sliding scale. So this end would be shaded in really heavily. Because that would be really dark, because it doesn't have much through at all. And then translucent, that's some through, and then transparent, that's all through. Okay, so transparent, that's all through, translucent, that's some light through, opaque, doesn't let very much light through at all, so it looks really dark. Simple.